this is going to be objective 31, and we are going to explore the natural exponential function. Okay, so we've talked a little bit about simple interest in investing money. Today we're going to talk about compound interest, and I'm going to get a little bit more with it and get into a little bit more of the mathematics with it. Okay, so you need to be introduced to the number E. Okay, it's a letter, but it represents a number, a certain number, kind of like, and it's the same thing like pi. Okay, it's the same thing as pi. Pi represents what? 3.1415 something. Okay, an irrational number. E represents a number as well. So let's figure out what E represents. Basically, the number E is defined as the value 1 plus 1 over n as n becomes large, as we start to raise it or it becomes exponential. Okay, so what I would like for you to do really quickly, and then I'll let you go, is I want you to take a minute and I want you to work this out. We're going to figure out what E is. Okay, so we're going to plug in 1 plus 1 over, what's my n for the first one? 10 raised to the 10th power. Okay, and you may have to put a separate parentheses around the 1/10. So I want you to figure that out for me. Let's do the first one together, and then I'll let you do the rest of them. Okay, I'll just give you kind of a couple minutes. So somebody tell me, when you plug in your calculator, 1 plus 1 over 10 raised to the 10th power, what do you get? What number? Let's see if we get it. I got one that put it in. Put it in your calculators real quick and tell me, what number do you get? Let's round it to the nearest. Let's go 3 places out. Nearest thousand. 2 point, like, go one more place. Go 3 places out. So 2.594. Did everybody get 2.594? Okay, so let's make sure you can put it in and get it correct. I'll come around and help you, but I want you to do the next one and go ahead and fill out the whole chart. So 1 plus 1 over 100 raised to the 100th power. And tell me what you get. And again, you may have to put parentheses around that fraction. So fill that chart out, and then what should happen, there's something that should happen the bigger you get. All right, so what do we get when we plug in 100? 2 point, hold that thought, 2.705, okay? What do we get when we plug in 1,000? 717? Okay, what about 10,000? 2.718? 2.718? 2.718. So what happens as we get larger? It gets closer. It converges to a certain number, and that certain number is known as E. The book uses E is equal to 2.71828. If you want to write that down, okay? That's what E is known as. Now instead of us like plugging in 2.71828 every single time, 7.1828 every single time, we just plug in the variable E. Does that make sense? Because we know, and E is used in a lot of different formulas, and compound interest is one of the formulas that it's used in. Okay, so I do want you to show you where the E button is on your calculator. So if you go on your calculator down the left side, do you see where it says log and ln? Do y'all see where it says log and ln on the left side? If you look in blue above the ln, what do you see? E to the x. So if you hit second ln, that's the letter E. If I want the actual function E, does that make sense? That's when you're just typing in. Huh? Oh, does it give it to you too? So try them both out. E to the x, if you're going to raise e to a certain power, I use e to the x button, and you can just put in e to the third. It gives you what? And we're going to round it to 5 decimal places, so 20.0855. How about 4? Because the 6 makes the 3 go up. Now, what if I put in the same thing? What if I put in 2.71828 raised to the third? Would you get about the same number? Because that's what E is. E is that number. Does that make sense? Okay. And you can try the E above the division sign and raise it to the third power, and it gives you the same thing. Okay. So what do you get when you put in number 2? Levi, what do you get when you put in number 2? You got, everybody agree with that? 1.17721. Okay, how about e to the 4.8? 121.51042. And again, everybody understands this would be the same thing as if we took that number, 2.71828, and raised it to that same number, okay? But we just use the letter E instead. Any questions about that? Everybody good? Okay. So let's talk about this. Yes, I can read it to you out loud. I'm sorry that it cut off. I don't know why it cut off the top and the bottom, so I had to fill in. All right, it says, an infectious disease begins to spread in a small city, population of 10,000. After T days, okay, T is the number of days, the number of persons who have succumbed to the virus is modeled by the function. So I'm giving you the function. This is not a specific formula. It's just the formula that's modeled for this particular question. Does that make sense? So V at T is equal to 10,000 divided by 5 plus 1245 e raised to the negative 0.97t. Negative 0.97t. Okay, and that's just the model for this. Okay, so basically V at T is going to give us how many people are infected over a period of time. Okay, does that make sense? And notice we have T, as T increases, T is where? T is the part of the exponent, meaning it's going to grow how? How does something, an exponential function, grow? It starts out slow and then it shoots up really quickly, right? As time passes, it's going to start out slow. So we're going to look first at how many people were affected initially, meaning how much time has passed? None, meaning T is equal to 0. Okay? So what we're going to do is we're just going to plug into this formula, and we're going to put a 0 where the T is. So we will have V at T is equal to 10,000 divided by 5 plus 1245 e to the negative 0.97 times, got to write 7, times 0. Okay, we're plugging in 0. Okay, so if I were you, first thing I would do is I would times your exponent. It is 10,000 divided by 5 plus 1245. This is going to end up being, what's negative 0.97 times 0? 0. Basically, it's going to end up being e to the 0. Okay? So if I were you, you could put this all in your calculator, but I would put the denominator in parentheses. Okay? And you're just going to plug it into your calculator. So when you plug this into your calculator, how many people are infected initially on day 1? No time has passed before we even, actually it's day 0. 8 people have been infected. Okay? That's initially. Okay? Did everybody get A? Did anybody in your group get 8? Huh? Okay, well, I can wait. You just got to tell me. We're going to figure out the number of infected people after 1 day, 2 days, and 5 days. That means after 1 day, T would be what? 1. After 2 days, T would be 2. And after 5 days, T would be 5. Correct? So I'm just going to plug these in. Now, when you plug them in, you have to be cautious, careful, conscientious, and you have to plug in with parentheses. Okay? So this is 10,000. Now, do I have to put the 10,000 in parentheses? No, because it's the only thing in the numerator. But because I have multiple things in the denominator, and if it were me, just to make sure that I get it done correctly, I would put negative 0.97 times 1. I would work this part out first before I put it in the calculator. Okay, you don't have to, but you do have to make sure you put parentheses all around that. So if it were me, I would do 10,000 divided by parentheses 5 plus 1245 e to the, what's negative 0.97 times 1? Negative 0.97, right? So I would just raise it to that. Okay, I would work the exponent out first before you put it in. So tell me, I'm just going to put up here, day 1, day 2, and day 5. I would do whole number because we're talking about what? We're talking about people, and we can't take halves of people. Okay? So let me just give you a couple minutes to work those out, and then we'll take a look at them. So, okay, so how many people are infected after 1 day has passed? Say it again. 21. If we round, we're just rounding to the nearest whole person. Okay? 22, or after 2 days has passed. How many? 54. And how about after 5 days has passed? Yeah, notice this is why it's growing. Like if we plotted this, you know, you have on day 1 it's only 8 people, and then it starts to go up. Let me do it in purple. It starts to go up from here, and then all of a sudden it goes like that, and it skyrockets. That is representative of an exponential function. Okay? Let me do one more thing today, and then we'll kind of call it a day, and we'll pick this up tomorrow. Okay? Let's go ahead and get into compound interest. Okay? This formula, everybody listen, this formula you will need. You may even want to put this on your colored sheet for your exam. Okay? This is, so we're going to do lots of problems. That last problem on the disease problem, I gave you the function. So if I give you a function, then you just use that particular formula for that particular problem. But when we are talking about compound interest, we are going to be using this formula quite often. Okay? A at T means, A at T is, and I've given you what each piece means. It's the amount after a certain number of years. Okay? P is your principal. I didn't add that in there. We might want to add that in there. P is the principal. I don't know if this is P-A-L or P-L-E. Which is it? P-L-E? Nope, it's P-A-L. It is. It's P-A-L. Is the principal. Principal means it's the original amount of money that you invest, right? Okay, in this case, we're not talking about loans. We're just talking about we're investing money, okay? R is the interest rate per year. N is the number of times interest is compounded per year. And T is the number of years. So I want to talk about when you compound something. Like if it only gets compounded 1 year, that means like the example of the video I gave you. That was only compounded each year. Does that make sense? So she put in a certain amount of money, and she kept the money. It earned a certain amount of interest each year. Everybody with me? And then at the end of that year, what did they do? So listen to me, and this is the last thing I'm going to say for today, okay? She put her amount of money in. At the end of that year, she earned $100. What did she do with that $100? She kept it in there, and then they refigured it based on that amount of money. So tomorrow we're going to talk about when you compound it annually. It means it got refigured each year, okay? What if I compound it twice a year? Meaning after 6 months, we see how much money you made, and then we like base it off that amount of money. Does that make sense? And then at the end of that year, we do it again. Are you going to make more money if you compound it more often? Yes. So we're going to talk about what do you get when you compound it yearly, then compound it monthly, or bi-yearly, or quarterly. What does it mean quarterly? If I compound it quarterly, it means every 4 months. Okay, and we'll talk about that, and you'll earn more money.